Hello. Today we will study photoelectric effect. Okay. So photoelectric effect was proposed by scientist name everyone knows, I think, Albert Einstein, right? And he received a Nobel Prize for this effect. So let us study what is photoelectric effect. Okay. So we will study it in very simple terms. Okay. Let's say this is a metal plate. Okay. This is a metal plate. Now you know metal plate is made up of what? Electrons. It has electrons in the upper surface. Okay, and everywhere there are electrons, right? So what is photoelectric effect is whenever we induce light, okay, means there are light rays which are falling, on the surface of the metal plate. Okay, so from this metal plate, okay, gradually when the light rays, the incident light rays frequency is increased, okay, then we saw that the electrons used to released from the surface of this metal plate. Okay, so electrons get released, but one thing note that at very less intensity, okay, the light rays which are falling, the electrons were not releasing. Okay, then when we increase the intensity, or let's say frequency of the light rays, then electrons are increasing and the electrons released. Okay, so now if we say that the incident light rays, light is a form of energy, right? So light is a form of energy, and this energy is represented by hc by lambda. Okay, where h is the Planck's constant, c is the speed of the light, and lambda is the wavelength of the light energy, light you can say. Okay, now this is what? This is the formula for energy of light rays. Now it is observed that there must be a minimum value after which the electrons get released. Okay, there must be a minimum value of energy after which the energy get released. Below that the energy doesn't release. Okay, now this formula is also written as E is equal to h nu, where nu is the frequency of the light rays. So initially, okay, let's see, the frequency is for about 1 nanometer. Okay, you can say one only. So in that case, what the frequency, if it is 1 second, then the energy is not released. Okay, but as we increase the frequency, let's say for about when the frequency is 5 second inverse, then the energy is sufficient to release the electron. Okay, and as we increase the energy, more number of electrons get released from the surface. Okay, so the minimum amount of energy, okay, listen to this, minimum amount of energy required is called the work function, okay, which we represented it by phi. Okay, so let's say phi is equal to h c by lambda naught or h nu naught. Okay, so this is the minimum amount of energy that is required to release the electrons. Now one more important thing is the electrons on the surface are easy to release as compared to the electrons which are in depth of the surface. Okay, second important thing, you know that in chemistry we study there are metallic bonds, and ionic bonds is there. So due to those ionic bonds, we have to if we want to release this particular electron, okay, this particular electron is attracted by its lowermost electron, its sidemost electron, all these are attracting. So there are some amount of ionic bonds are there. Okay, so if we are releasing this electron, that means what? We are surpassing that electrons ionic bonds, and that is this work function is the minimum amount of energy. What happens if we apply more amount of energy? Okay, so see, when we apply more amount of energy, okay, then that energy is converted into the kinetic energy of that electron. So electron will be released from the surface, okay, and it will move like this. like it will move for suppose in this way. Now if we amount a huge amount of energy, then the electron will move this. So what the velocity is more, that is the kinetic energy is more, and the formula of kinetic energy is what, half m v square. So where m is the mass of the electron, v is the velocity of the electron. Okay, now if we apply energy conservation, we will see E is equal to what? E is equal to work function plus kinetic energy, and this is the maximum kinetic energy of an electron. Okay, this is the maximum kinetic energy that an electron can possess. Now what is E? E is the applied energy, phi is the work function, and Ke is half m v square. Now let me write this in terms of hc by lambda. So this is hc by lambda. Okay, phi is what? Phi is hc by lambda naught plus half m v square. Okay sir. Now we can write in another form, that is h nu is equal to h nu naught plus half m v square. Okay, so many numericals, and this is a very important topic for CBSE boards. Okay, as well as NEET and JEE also, but CBSE boards most of the times they ask question from this. Okay, now let me draw a graph. Okay, let me plot a graph. So this is the graph between let's say we will plot a graph on frequency, okay, that is nu, frequency and the kinetic energy. Okay, frequency and the kinetic energy. So see, when I apply zero frequency, will there be any release of electron? No. Then I gradually increase the frequency, that means I am gradually increasing the energy, but there is no energy, there is no electrons. Okay, there are no electrons that are coming out of the surfaces. Okay, since there are no electrons coming out of the surfaces, the kinetic energy will be what? Zero. Now at a certain point, let's see here, the electron starts means coming out of the surface. So from here, now as I increase the frequency, what the kinetic energy gets increases linearly. Okay, now if I extend this graph, okay, so we will see that it will intersect here, and this will be our work function, that is phi. Okay, so this will be our minimum value or work function, you can say. This is the minimum frequency value where the electron is released. Okay, so the setup of the photoelectric effect was something sort of that. Here was a metal plate, here is a metal plate. Okay, and in here, let's see, let me draw first of all. Okay, now these two metal plates will be connected by battery. Okay, so these two are metal plates, and from here we will incident the light. Okay, so as I incident the light, electron gets released from the surface. Electron will release from the surface, it will move towards this, move in this direction. Okay, why electron will move in this direction? This is because due to this battery. See, this battery, this is our plus, this is our minus, so this is our higher potential and this is our lower potential, right? And we know from the higher potential to the lower potential, there will be electric field. Okay, so electric field will be in this direction, and everyone knows that if electric field will be in this direction, then the force will be in the opposite direction. So the electron, let me tell, this electron will experience a force that is Q into E, and instead of Q we can say E into E, because Q is the charge of the electron. So E into E, this much force is applied, and as the force, if I say force I am applying force on the electron will move in this direction, right? So electrons will move in this direction. Let's see, the voltage of this is V. Now the electron will move here, and then from this direction we can say there is the flow of current. Okay, now the flow of electrons, what? Flow of electrons means current only. Okay, now see, this is our what? This is our battery, external battery. Okay, now tell me, if I increase the voltage, what will happen? What will happen? See, if I increase the voltage of the battery, then the electron will what? There will be more force. Okay, there will be more force, and electric field will be stronger. Increase of voltage means increase of electric field. Increase of electric field means increase of our force, and if the force is increased, the kinetic energy, that is half mv square, will also get increased. Okay, so this is the photoelectric effect for which our scientist Albert Einstein received the Nobel Prize. And there are many questions. For suppose this hc by lambda, we can say E is equal to hc by lambda. Okay, we can also write it as 1240, okay, by lambda, in which the lambda will be in nanometer. Lambda will be in nanometer, or we can say 12400 by lambda, okay, where lambda is in Armstrong. Okay, and lambda will be in Armstrong, and this energy value will be in eV, electron volt. This energy value will be in electron volt. Okay, okay. So let me say that the work function. Okay, the work function of this setup, is 2.5 electron volt. 2.5 electron volt. Okay. Now tell me the kinetic energy of the electron. Tell me the maximum kinetic of the electron. So hc by lambda is equal to, see, this is the work function. Okay, now applied energy, if I say the applied energy is given as 4 electron volt. Okay, so no need of this hc by lambda. E is equal to what? 5 plus ke. I know 5 plus ke. So what is E? E is my 4 electron volt. Phi is 2.5 plus what is the kinetic energy? Let me keep it as ke only. Okay, ke maximum. So from here I can say it will be 1.5 electron volt. That is the maximum kinetic energy that an electron can possess. One more question, sir. All the electrons will have this much of kinetic energy? No. Okay, there are certain electrons which can have this kinetic energy value. Okay, but all the electrons will not have this kinetic energy value. Okay, it will be always less than this value, but this is the maximum value. So if an electron is there, that will possess at max 1.5 electron volt. That is the maximum value of kinetic energy. Okay, so I hope it is clear to you. Okay, thank you.